10 tons of steel raced through the desert without a single person inside. No driver, no gunner, no commander. A 30-millimeter automatic cannon rotates on the turret. A thermal imager scans the horizon, yet there is not a single seat or a single crew hatch inside the hull. This machine knows no fear, feels no pain, and does not ask for evacuation when it takes a hit. It can be destroyed, but an hour later, an operator tens of kilometers away will simply switch to controlling the next identical machine and continue the fight. This is not a sci-fi movie script or a concept from a military exhibition presentation. This is the Ripsaw M5, the world's first fully electric robotic tank, which the American Army is already preparing for serial production. And the most chilling thing about it is that you will not hear its approach until it is within 100 meters of you. Meanwhile, the roar of the Abrams tank's gas turbine engine is audible from a distance of more than a kilometer. But to understand how humanity reached the point of creating a combat robot that can replace an entire tank crew, we must go back to the very beginning of this story. And it began not in a secret Pentagon laboratory or at a testing ground in Nevada, but in an ordinary garage in a backyard in the state of Maine. Mike and Jeff Howe are twin brothers who, from the age of 7, built log cabins in the woods and took apart everything they could get their hands on. By the early 2000s, they had turned into obsessed, self-taught engineers who dreamed of one idea: to build the fastest tracked machine on the planet. Not for war, not for an army contract, but simply because they wanted to prove that two guys from the hinterland could create something that entire design bureaus could not achieve. In their garage, the Howe brothers started from scratch. They manually machined steel track links, designed the suspension themselves, and experimented with engines. The result of their work was named Ripsaw, and this name turned out to be prophetic because their creation literally bit into any surface. The first prototype accelerated to almost 100 kilometers per hour off-road. This was despite the fact that most production-tracked vehicles of that time barely squeezed out 60 on a smooth road. The brothers posted videos of their tests on the internet, where their homemade robot on tracks dashed across snowy fields, performing wild turns and jumps. The clips went viral, and Hollywood noticed them before the military did. The Ripsaw appeared in several major blockbusters, including the 8th installment of Fast and Furious and Mad Max, Fury Road. But the real turning point in the machine's fate happened in 2005. The Defense Advanced Research Projects Agency, DARPA, announced an open competition for the creation of autonomous ground vehicles. This was a time when America was bogged down in Iraq and Afghanistan. Every day, convoys with soldiers were blown up by improvised explosive devices planted on the roadsides. The Pentagon was desperately looking for a way to remove living people from the line of fire, and the DARPA competition became one of the steps in this direction. The Howe brothers applied with their garage project, and their machine caused a sensation. It did not just pass the obstacle course, it shattered all expert expectations for speed and maneuverability. The military saw the potential, and from that moment, the Ripsaw ceased to be a toy of two inventors from Maine. But a fast-tracked platform is one thing, and a full-fledged combat machine is quite another. The journey from a garage prototype to what is now called the M5 took almost 20 years and required solving dozens of engineering tasks that were previously considered unsolvable. One of the main problems of any tracked vehicle is that when the suspension compresses on uneven ground, the track belt sags and a link can slip off. For an ordinary tank, this is an inconvenience. For an unmanned machine without a crew, it is a disaster, because there is no one to get out and tension the track back on. The Howe brothers came up with a solution that was later protected by a patent: a spring-loaded wheel in the front part of the hull that automatically extends when the suspension compresses and keeps the track in tension. In the entire history of Ripsaw testing, it has never lost a track, a record that no production tank in the world can boast. In addition, the brothers completely redesigned the construction of the track links themselves. Instead of the standard pin and bushing system used in tank building for decades, they created a lightweight track link weighing less than 1 kilogram, which is approximately 90% lighter than similar elements on production combat vehicles. They molded each such link by hand, and this resulted in an incredible reduction in the total mass of the chassis. By the end of the first decade of the 2000s, the Howe Brothers Company, named Howe and Howe Technologies, was already working in tandem with Textron Systems Corporation, one of the largest defense contractors in the United States. It was this partnership that allowed the transformation of a fast-tracked all-terrain vehicle into something fundamentally different, a full-fledged fifth-generation robotic combat platform, which received the designation M5. And this is where the most interesting part begins, because the concept of this machine breaks everything we have known about tanks for the last 100 years. A classic tank is, essentially, an armored box inside which 4 people try to survive and simultaneously conduct battle. The commander, gunner, loader, and driver occupy a huge space that must be protected with thick sheets of steel and composite armor. It is the crew that determines the machine's dimensions, its weight, the location of hatches, the thickness of protection, and even the shape of the hull. Remove the people from the inside, and you get a completely different engineering task. This is exactly what the creators of the Ripsaw M5 did, and the result overturned all conventional ideas of what a combat machine should look like. The load-bearing structure of the M5 has nothing in common with the armored hull of a conventional tank. Instead of armor plates welded together, the engineers at Howe and Howe Technologies applied a frame of steel tubes welded at calculated angles. This solution came directly from motorsports, specifically from the world of NASCAR racing, where a space frame made of tubes provides a 50% increase in strength at half the weight compared to a solid metal body. For a combat robot that does not need to protect soft human bodies inside, such an approach turned out to be ideal. The tubular frame is simultaneously light and incredibly rigid, and upon impact, it deforms predictably without falling apart, as sometimes happens with cast hulls. Due to the absence of a manned compartment, the M5 received a silhouette that seems impossibly low for a combat machine. The height of the hull is only 70 centimeters, and that is without the turret. For comparison, the height of the Abrams hull without the turret exceeds 1 meter, and the total height reaches 2.5 meters. The low profile provides a colossal tactical advantage. The machine is significantly harder to detect visually and practically impossible to spot behind terrain features, bushes, or even tall grass. The center of gravity is located extremely close to the ground, making the platform exceptionally stable on steep slopes and during sharp maneuvers. During tests, the M5 tipped onto its side and continued moving, which is physically impossible for a conventional tank weighing 60 tons. But the main revolution of the M5 lies not even in the hull construction, but in the power plant. The developers claim that this is the world's first fully electric-tracked combat vehicle. The electric motor fundamentally changes the rules of the game on the battlefield for one simple reason. It produces almost no noise and practically no heat. The Abrams gas turbine engine roars so loudly that it can be heard from a distance of over 1,000 meters on a paved road, and the heat signature from its exhaust is visible to any thermal imager from several kilometers away. When moving, the M5 becomes audible only when it is 100 meters away. This is the distance of a single rifle shot. In a night battle, when the enemy relies on sound and heat signatures, the electric robot turns into a ghost that appears out of nowhere. The mass of the medium version of the M5 is approximately 10.5 tons, which is exactly 3 times less than that of the Bradley infantry fighting vehicle. At the same time, the platform is capable of carrying a payload of up to 3.5 tons, which is a colossal figure for a machine of this class. This is where modularity comes into play, something often talked about in the defense industry, but which, in the case of the Ripsaw, truly works. The flat upper deck of the hull is designed so that almost any combat module can be installed on it, from a remotely controlled turret with an automatic cannon to an anti-tank missile launcher, from a container with loitering munitions to engineering equipment for demining. Replacing one module with another does not require redesigning the platform itself. It is enough to remove one block and install the next. Scalability goes even further. Using the same suspension units, the same track drive construction, and the same tubular frame principle, the engineers created an entire family of machines of different sizes. The light version weighs about 4 tons and is capable of carrying 1.5 tons of cargo. It is so compact that it can be dropped from a transport plane by parachute and immediately put into battle. The medium version, with a gross weight of 10.5 tons, became the main candidate for the Army's Robotic Combat Vehicle program. According to available data, a heavy modification for more serious tasks is also being developed. All these variants are united by one engineering philosophy: maximum capabilities with minimum weight, like a construction set from which you can assemble exactly the machine needed for a specific operation. The cost of one Ripsaw M5, according to various sources, ranges from $200,000 to $750,000 depending on the configuration. For comparison, one Stryker armored personnel carrier costs the American budget approximately $5 million, and the price of a modern Abrams has surpassed $10 million. This means that for the cost of one tank with a crew of 4, the Army can receive from 15 to 50 robotic combat units. And even if the enemy destroys half of them, the losses will be measured only in money, not in lives. This economics of war became the main argument for those generals in the Pentagon who are pushing the Robotic Combat Vehicle program. On the flat deck of the Ripsaw M5, weapons can be installed that turn the 10-ton platform into a real armor killer. The main combat module for the medium version became the Protector RT-40 remotely controlled turret. And this is by no means a random choice. It was this turret that the American Army originally integrated into the Stryker Dragoon modification, and it has already been tested in real conditions. In 2021, the United States Army conducted the first firing tests, where an M5 with the Protector turret installed fired at targets without any human involvement inside the machine. The operator was at a safe distance and controlled the process remotely. The heart of this turret is a 30mm automatic cannon, which is capable of hitting light and medium armor at significant distances. Infantry fighting vehicles, armored personnel carriers, fortified firing points. All these are legitimate targets for such a caliber. Experience from recent conflicts has shown that even heavy tanks are vulnerable to automatic cannons of this class. There have been recorded cases where 30mm gun shells disabled T-90 series tanks by hitting vulnerable zones of the side projection and the rear. A 7.62 caliber machine gun paired with the cannon provides the ability to hit personnel and unarmored targets without consuming expensive 30mm ammunition on every pickup truck or infantry position. However, if the enemy rolls out a heavy main tank onto the battlefield, an automatic cannon might not be enough. In this case, the M5 can carry a Javelin anti-tank missile launcher, one of the most effective anti-tank weapons in the world. The Javelin attacks the target from above, hitting the turret roof where the armor is traditionally thinnest. And it is this destruction principle that has made it a true nightmare for tankers around the world. Installing the missile system on an unmanned platform creates a situation where the robot can approach the enemy unnoticed thanks to its silent engine, launch, and withdraw without exposing a single living soldier to the risk of return fire. But weaponry is only part of what makes the M5 dangerous. The real strength of this machine lies in its eyes and ears. The Ripsaw Reconnaissance Complex is built on technologies from Teledyne FLIR, one of the world leaders in the production of optical electronic systems. A high-resolution daytime video camera, a thermal imaging camera for operation at night and in smoky conditions, as well as a laser rangefinder for precise distance determination to targets, are installed on the machine. All these sensors are combined into the FLIR 360 all-round vision system, which is mounted on a stabilized, gyro-stabilized platform. This platform compensates for the shaking and rocking of the hull when moving off-road, allowing the cameras to maintain a stable picture even at full speed. The spectral observation system is capable of working in fog, heavy smoke, and minimal visibility conditions, giving the operator the ability to see the battlefield when the ordinary human eye cannot distinguish anything beyond its own outstretched hand. However, this technological advantage has a flip side. If the optical electronic complex fails due to a fragment, a bullet, or even mud on the lens, the operator loses contact with the surroundings. The machine effectively goes blind, turning from a formidable hunter into a helpless target. It is this vulnerability that the designers tried to compensate for with one of the most unusual solutions in the history of military robotics. The Ripsaw M5 is a carrier for 2 autonomous reconnaissance drones, which are stored directly in the machine's hull and launched without human involvement. The first is the Skyraider R-80D quadcopter. It extends from a special compartment in the rear of the hull, takes off vertically, and can stay in the air for up to 50 minutes, reaching speeds of up to 50 kilometers per hour. The drone is capable of carrying a payload weighing up to 2 kilograms, allowing for the attachment of additional cameras or even a small munition. Rising above the battlefield, the Skyraider gives the operator a view from above, turning the robotic tank into a mobile reconnaissance hub with an aerial component. The second drone is a ground robot, designated as the Marsupial, with an operating radius of up to 1,000 meters. This small wheeled vehicle is capable of climbing stairs, penetrating inside buildings, and conducting reconnaissance in confined spaces where the 10-ton platform cannot physically fit. The Marsupial has its own observation turret, as well as a robotic manipulator arm for working with suspicious objects and obstacles. Together, these 3 elements, the tank itself, the aerial drone, and the ground scout, form a self-sufficient combat group capable of conducting observations simultaneously on the ground, in the air, and inside structures. And all of this is managed by a single operator sitting in safety far behind the line of contact. In August 2023, the United States Army officially launched the next stage of the Robotic Combat Vehicle program. And this stage resembled a harsh reality show more than an ordinary military procurement. 4 defense companies were given exactly 365 days to present their prototypes and compete for a contract worth $24 million. Each of them brought their own vision of what the robotic tank of the future should look like to the competition. And the differences between these machines turned out to be striking. The first contender was Textron Systems from Maryland, which entered the Ripsaw M5 into the competition. Behind them stood the many years of experience of the Howe brothers and the real results of the 2021 firing tests. The second participant was General Dynamics Land Systems from Michigan, one of the heavyweights of the American military-industrial complex, which built the Stryker armored personnel carrier and the Ajax infantry vehicle for the British Army. General Dynamics brought its own platform, which they called the TRX inside the company, a 10-ton tracked chassis with a completely different philosophy of use. While the Ripsaw bet on direct fire combat, the TRX from General Dynamics demonstrated something more sophisticated. Vertical launch containers with 2 types of Switchblade loitering munitions were placed on the back of the TRX. 22 Switchblade 600 munitions were packed into tubular launchers in the rear of the machine. Each such kamikaze drone is capable of loitering over the battlefield, waiting for the operator or commander to detect a target, and then diving onto it with a cumulative warhead capable of penetrating armored vehicle armor. In the nose section of the TRX, another 24 small Switchblade 300 munitions with a fragmentation warhead were placed to hit personnel and unarmored vehicles. In total, one platform carried 46 kamikaze drones, turning into a mobile arsenal that could shower the enemy with a swarm of drones while remaining outside the direct fire zone. The third contestant was Oshkosh Defense from Wisconsin, a manufacturer of tactical military vehicles with a history dating back to 1917. In more than a century of work, Oshkosh has produced over 190,000 tactical vehicles for the armies of more than 20 countries around the world. The fourth participant was MCQ from Virginia, a small but aggressive contractor that openly stated they came to the competition not to make friends, but to win. But the competition was only the tip of the iceberg. Behind it stood a much larger strategic concept promoted by Brigadier General Jeffrey Norman, director of the Next Generation Combat Vehicle Cross-Functional Team. General Norman explicitly stated that integrated human-machine teams are the future of successful ground combat. His words were not just a pretty phrase for the press. Behind them lay a specific tactical doctrine intended to change the very structure of the American ground forces. The essence of the doctrine boiled down to the concept of the loyal wingman, borrowed from aviation. Just as the United States Air Force plans to use unmanned fighters in tandem with next-generation manned aircraft, the ground forces intend to create mixed units where robotic machines act in pairs with Abrams tanks, the new M10 Booker light tanks, and Bradley infantry fighting vehicles. Robots are sent forward, taking on the most dangerous work: route reconnaissance, detecting ambushes, provoking enemy fire, and identifying their positions. Living crews remain behind, receiving a full picture of the battlefield through the robot's cameras and sensors, and enter the battle already understanding where the enemy is and what they are armed with. This tactic was not born from theoretical reasoning in staff offices. Recent conflicts have clearly shown how vulnerable large combat platforms are on the modern battlefield. Relatively cheap anti-tank missiles and loitering munitions destroy machines costing millions of dollars along with trained crews whose instruction took years. One shot costing a few $1,000s destroys a tank costing $10 million and 4 specialists, the training of each of whom cost the state hundreds of thousands. The mathematics of this war does not favor the side that relies exclusively on manned equipment. The robotic tank changes this equation radically. Each pair of robotic machines is controlled by 2 operators and 1 sergeant coordinator, who are in a command vehicle outside the direct fire zone. If the enemy destroys a robot, the crew loses a unit of equipment but does not lose a single person. The operator simply switches to controlling the next machine and continues performing the task. For an army that for decades built its doctrine around saving the lives of its own soldiers, this became an argument that outweighed all technical doubts and bureaucratic obstacles. For all its impressive characteristics, the Ripsaw M5 and its competitors in the robotic combat vehicle program remain a technology in the infant stage of development. And this infant has enough serious illnesses, each of which could put an end to the very idea of a robotic tank if engineers do not find solutions in the coming years. The first and perhaps most frightening problem is vulnerability to electronic warfare. A robotic tank, stripped of its crew, is entirely dependent on the communication channel between itself and the command vehicle. Interrupt this channel, and a multi-million-dollar combat platform turns into a useless pile of metal in the middle of a battlefield. Jamming the radio signal, intercepting control, or injecting false commands, all this has long since ceased to be a plot for sci-fi action movies and has become a real tool of modern warfare. Ukrainian military personnel have repeatedly demonstrated how to intercept control of enemy drones, redirect them, and use them to detect and destroy enemy positions. What works with a flying drone can theoretically work with a ground robot too. Only the consequences will be much more serious, because a captured robotic tank with a 30mm cannon on board is a weapon that can turn against its own. This is why one of the key Pentagon requirements for the robotic combat vehicle program was secure communication with military-grade encryption. According to available data, the United States Department of Defense has invested billions of dollars in the development of fifth-generation wireless network infrastructure, specifically for the needs of combat robotics. The task is to ensure a continuous encrypted data transmission channel between the operator and the machine under conditions of active electronic countermeasures from the enemy. How far from the command vehicle a robotic tank can operate with a stable signal? This information remains one of the most closely guarded secrets of the program, and no open source gives a clear answer to this question. The second critical problem is energy supply. The electric motor gives the M5 stealth and a low heat signature, but in return creates a headache with batteries. The charging time for a Ripsaw battery is comparable to the charging time for a civilian Tesla electric car, which means hours of downtime. On a battlefield where the situation changes every minute, multi-hour charging is equivalent to being out of action. Finding a socket in the middle of a combat zone is, to put it mildly, a non-trivial task, and no network of field charging stations will solve this problem in conditions of maneuver warfare when units are constantly moving. For this reason, developers are actively promoting a hybrid power plant, combining an electric motor with a diesel generator as an interim solution until battery technologies make a qualitative leap. However, a hybrid scheme inevitably increases the thermal and acoustic signature, partially negating the very advantage for which the electric motor was chosen. The third problem is more fundamental in nature. Despite all the achievements in the field of artificial intelligence, a living human still navigates a complex situation significantly better than any set of sensors and algorithms. An experienced driver-mechanic feels the machine, intuitively chooses a route between craters and debris, and instantly reacts to changes in the situation. A robot follows a program and sensor readings, which can be blinded, soiled, or damaged. Improving obstacle recognition algorithms and perfecting navigation systems is continuous, but reaching the level of human perception is still far off. And we are talking not only about driving, but also about technical maintenance in field conditions. When an ordinary tank loses a track, the crew gets out and tensions it back. When the same thing happens to an unmanned machine several kilometers from the nearest friendly positions, someone has to go there and repair it under fire. And this creates a whole complex of logistical problems that do not yet have an elegant solution. Finally, a question hangs over the entire program, the answer to which will determine the future of not only robotic tanks, but all military robotics as a whole. Who makes the decision to open fire? A human or a machine? So far, the United States Army stands firmly on the position that only a living operator can pull the trigger. But as artificial intelligence systems become faster and more accurate in detecting and classifying targets, a moment will inevitably arise when the speed of decision-making by a computer becomes critical for victory. If an enemy robotic tank fires autonomously, while your robot waits for confirmation from an operator with a delay of a few seconds due to the communication channel, the outcome of the duel is predetermined. The final prototypes of all 4 contestants were presented in 2024. The name of the competition winner should be announced in 2025, and the United States Army expects to receive its first fully combat-ready robotic combat vehicle unit by 2028. The robot race has already begun, and the stakes are not a trophy cup, but dominance on the battlefield of the coming decades. If you like this story, support the author with a like. Write in the comments whether you think robots will replace living tankers, and be sure to subscribe to the channel so you don't miss new episodes.